Welcome to the third and final Arduino lesson as part of this course. In this lesson, we'll be using a lot of the skills, circuits, and coding that we've used in the previous lessons. Overall, we're going to make a mission control panel that will use buttons, LEDs, a motor, and will even incorporate an emergency stop system. So let's get started. First, let's get a new circuit. Now, I've done that already, so now we're going to go to Components. We're going to go to Starters Arduino, and we're going to get the breadboard. We're just going to drag it and place it here. Now, a breadboard is a type of component that allows us to connect different components such as LEDs and resistors and buttons all together without having to solder or manually wire each component together. And it'll save us a lot in the future. When we look at the breadboard, it's important to make a few notes. First, these 5 connections are all connected, and each column is connected together in these sets of 5. However, A, B, C, D, and E here are not connected to F, G, H, I, and J. The other important thing to know is that for this row of negative, all the pins are connected and all the positives are connected here, and the same here. This whole top row is connected and this row is also all connected. The next step, once we have the breadboard set up, is to add buttons. So we're going to go to Basic Components. We're going to grab a push button. And we're actually going to use 4 of these. So I'm going to place one there. I'm going to place another one here, another one here, and then I'm going to add one more and place it right here. Now when we look at this, we can see that there are 4 pins on each of these buttons. And the way that we placed it, none of the 4 pins are connected to each other. This pin is not connected to this one, and this one's not connected to this one, and this one's not connected to any of the others either. This is very important for the circuit. None of these pins can be connected. After we add the buttons to the circuit, we're now going to add some LEDs. It's important to know for the buttons, it doesn't matter which side we connect to the Arduino and which to the ground. However, for the LEDs, they do have polarity, which means they have to be wired in a certain way. So first we're going to grab 4 LEDs, put them here, here, and this will be our third one for the main system, and we'll have one more LED here for the abort system. Now we can change the color of these LEDs, so I'm going to change the first 3 to be all green. Now that we have all the LEDs placed, let's wire them. So one thing we learned in one of the previous lessons is that we have to put a resistor in so that the LED does not blow up. So let's add the resistor, and we're going to connect it to the left side of the LED, and we're going to connect it to ground. You could use a wire to go from the LED to the resistor to ground, but in this case we can actually make it simpler and just use the resistor to connect the cathode of the LED to ground. Next we're going to add pin 8, and we're going to connect it to the right side, or the anode of the LED. We're going to change this to be a yellow wire. We're going to do the same for all of the LEDs. So we'll connect the cathode to ground of the second LED, and then we'll add a wire and connect it to pin 7 on the Arduino. We'll do the same here. Connect the third LED to pin 6. We'll connect the final LED to ground using this resistor, and we'll connect the final LED to pin 5. The system that we've built so far is all part of the input system. The way this will work is we'll press this button and it will turn on this LED. Then, if this button was already pressed, we can press the second button to turn on this LED as well, so we'll have both LEDs on. Then, when we hit the third button, after the other 2 have been pressed, the third LED will also turn on, and it will activate the motor. We also have this LED, which is controlled by this button. If the user wants to abort or use an emergency stop, they can press this button, and it will turn off all the LEDs, and it will turn off the motor, and this light will turn on, indicating that there is a problem. After we've finished our input stage, let's work on the output for this circuit. So the first thing we're going to need to do is we're going to go to Basic again, and we're going to go to DC Motor. We're going to click this and drag it and put it here. Now we're actually also going to add one more LED that will act as a diagnostic. That way we know if we wired something wrong or if there's an issue with the motor. So we're going to drag one more LED here, and then we're going to add in a resistor. We're going to connect everything to ground right away. Let's change this LED to be blue so we don't get it confused with the other systems. Next, to wire everything, let's connect the LED, the right side of it, to pin 4, and let's change this to also be blue. Then we'll connect the black terminal or ground to ground on the breadboard. We'll change this wire to be black. And finally, we'll connect the red terminal or positive terminal to pin 3 on the Arduino. And let's also change this to be blue. Now that we have the wires all hooked up for our input and our output, all the hardware side of this is all completed. So next, let's shift into the software design. Let's start working with the code. So we're going to click the Code tab. Now instead of using blocks like we have for the previous 2 lessons, we're going to use text due to the complexity of this circuit. So we're going to click blocks, and we're going to switch to text. And it's going to give us a window asking if we want to close a blocks editor. We're going to click Continue. So this is now the code using C++. There's 2 parts that are seen here. We have void setup and void loop. In the void setup, we're going to be establishing all of our connections and creating variables that we'll be using for the entire program. Then, in the void loop, this is where we'll actually be programming the circuit to conduct different functions. The first thing we're going to do here is delete this line, pin mode, and we're going to delete what's in the void loop as well. Next, we'll be adding the code that's already been provided. The first piece of code that we're going to add is creating integers. Now this will occur outside of the setup loop and the void loop. We're going to have a variable known as an integer which stores a number. Each one of these represents the pin number of one of the buttons, LEDs, or the motor. For example, LED pin 1 is set to 8. This is this wire, which connects the LED, as we can see here. This will be used later when we're setting up each of the pins on the Arduino. We've also created 4 Boolean variables, which are true or false variables. Each one of these variables can either be true or false. We'll be using this to track whether each of the buttons was pressed. The next piece of code that we're going to look at is in the setup loop. In here, we have to set each of the pins on the Arduino for a specific function. For example, all of the buttons have to be set so that they are inputs, so that we're reading a value. While as the LEDs, we're going to be outputting a value, so that Arduino needs to send an output signal. So we're using the variables that we set before for each of the LED pins, and we're setting all of the LED pins to be outputs. So LED pin 1, which is pin 8, is set to an output. Next, we're going to be setting all the buttons to inputs. Now it's also important to look at this piece right here, the input pull-up. This means we'll be turning the button on if the signal is low. And this is because we have each of the buttons connected to ground. So if the circuit is completed by pressing the button will be connected to low voltage. Since we have it set up this way, we want the input to be set to pull up so that it reads low values as a high value. And finally, we're setting our motor to also be an output, which is on pin 3. The next piece of code that we're going to look at is now in the main loop. We're going to start with an if statement. We want it so that if we press the first button, the first LED will turn on. So how can we do this? Well, we need an if statement. We've used this in the previous lesson, and now we're going to use it in a different programming format. In C++, this is how an if statement is set up. We want to say if, and then we want to set a condition. In this case, we want it where if the button is set to low and we don't have the abort button pressed, then we will turn on the first LED. So let's see what happens when we do this. Now we press the first button and the LED turns on. We want to continue this now for all of the LEDs. Now we added in all the if statements for all 4 of the initial buttons and for the output system as well. So we have our original if statement, which turns on LED 1. We've added another one for LED 2 here. Now this has one more addition, and it requires that B1 is true. Now B1 is a Boolean variable that we set before, and this represents that button 1 has been pressed. In this loop, when button 1 has been pressed, we turn on the first LED, and we also are setting this Boolean to be true. So now when we go to the if statement here, when we check to see if button 1 has been pressed, we can see whether or not it has, and if it has, it turns on LED 2. And we also set Boolean 2 to be true, meaning that the second LED is now on. We do the same thing for the third LED as well. However, in this case, we also are adding an additional statement for button 2 being pressed, and we're adding it so that the LED 5, which is our diagnostic LED here, is turned on, and our motor is also turned on, meaning the entire system is now powered on. We have one more if statement here, and this is looking at the abort system. In this case, at any point, if we press this button here, the entire system should turn off and this red LED should turn on, telling us that we are in a stop period. Now, to do this, we have to check to see if button 4 has been pressed, and that's what the statement is here. We also want to make sure that the button has not already been pressed, basically saying that we haven't aborted already. Then you can see we are going to turn off all of the LEDs by setting them to low. We're going to turn the motor off, and we're going to activate our Boolean B4 to be true, meaning that we are in abort mode. We also are setting all the other Booleans to be false, turning off all of the LEDs. Now that we have some code developed, let's test out to see if our code behaves as we expect. So we start the simulation, and the first good sign is that none of the LEDs are on, meaning that we accidentally turned them on. Now, let's press the first button, and we see that the LED turns on. That's a good sign. Let's try hitting the third button, just to make sure that it doesn't turn on too soon. And we see that it stays off. Next, let's click the second button, and the second LED turns on. And now we click the third button. And when we do this, we should see this LED also turn on, this one turn on, and the motor should start. So I'll click it. You can see the blue LED came on, the green LED. We can see that the motor is spinning at 5,555 RPM. Now let's say we wanted to stop the system. So we click the fourth button, and now everything stops, all these LEDs turn off, and the red LED turns on. Now there is one problem with our current design. Once we've pressed the stop button, we can't go back and do anything else. So we have to actually unplug everything and restart. But we could add a new feature in where if we press the stop button again, that the entire circuit will reset. So let's do that. We'll stop the simulation and we'll go back into the code and we'll add one more if statement. I've added in one more if statement right here that's highlighted. And this if statement will read if the fourth button is pressed and we've already been put into abort mode, meaning that we've already pressed the button. And what this will do is it will flash the LED that's right here, the red LED. It will flash it on and off 2 times, and then it will reset all of the variables. So it will set the red LED to be turned off, and it'll set all of the Boolean variables to be false like they were initially. Let's test out the code to see how it works. We'll start the simulation, and now when we press the first button, the first LED turns on. We see everything turns on just right, and now we hit the stop button, and now everything turns off. And let's click it one more time. We see it flashes, And now let's see what happens if we can try turning everything on again. We see LED 1 turns on, 2, and 3, and now everything's working just as we expected. Now we've completed this circuit and all its functions. Now there's many ways that this circuit could be modified, such as adding in more components or changing the code, and I encourage everyone who watches to try creating their own variation of this circuit. This system also represents a lot of critical control systems that have a lot of different applications. This could be used in a mission control room when launching an Artemis mission, or it could be used in a lunar colony for activating a critical life support system. This is just a very basic system, but it could be implemented on much larger scales that have lots of great applications in the exploration of space.